Good morning, everyone, and welcome to this lecture 8 for units in measurement. In the previous lecture, we have discussed some more applications of dimension analysis, and in which we have checked about the consistency of the equations and the methods to convert one system of units to another system. So these applications we have already done. And in the previous lecture, I have given you some practice problems. So the practice problems for lecture 7, these are the practice problems that I have given you. 2 practice problems were there. So some of you people have solved them, and others, they are having some doubts and problems in solving these things up. So let me solve them for you. And then I'll be giving you some more practice problems at the end of this lecture, so that you will be solving them and getting up the concept in a very effective manner. So let's start with problem number 1. And those who have solved them, they can check it that whether they have solved it correctly or not. So they can easily be checking it. All right. So let's do this. The solution to the practice problems from lecture 7. Problem number 1. It says that the time period of vibration, that is capital T, of a tuning fork, it depends upon 3 factors. One is length of its prong. Secondly, the density. And the third factor is the Young's modulus, denoted by capital Y. We need to derive an expression for the time period of the vibration for the tuning fork using the methods of dimension. So we know how to proceed in these problems. First, we need to take the factor whose formula we need to derive, that is capital T, and it is proportional to L, D, and Y. But we don't know to which powers of L, D, and Y they are proportional. So let's start it. T proportional, according to the question, T proportional L to the power A. This is our equation number 1, where L is your length. T is also proportional to D to the power B, where D is your density. And T is also proportional to the Young's modulus Y, having power C. So these are 3 equations that we can write. And from these 3 equations, when we combine them up, we can write the T proportional L to the power A, D to the power B, and Y to the power C. All right. Now, when you remove up the proportionality sign, there will be one constant. So you will be writing it like this. T is equal to K, L to the power A, D to the power B, and Y to the power C. Now, we need to write the dimensions of the quantities that are involved in our equation number 5 in both the sides. So first, the LHS and then the RHS. So LHS is your T only, so it is having dimensions T, because time period is the kind of time that has dimensions capital T only. K do not have any dimension because it is dimensionless constant. And L, it will be having dimensions as capital L. And D is your density, that is having dimensions as ml minus 3. And your Y is Young's modulus, that will be having the same dimensions as the pressure. I've told you when I have made you write the dimensions of various quantities that this Young's modulus, it has the same dimensions as we are having for the pressure. We know pressure is force upon area. So you can easily find it out as ml minus 1 T minus 2 for Young's modulus Y. So writing of the dimensions, you can write it like this. The dimension for the left hand side is capital T only. For right hand side, it is L, L to the power A. And then for D, we have written ml minus 3. That is the dimensions for density having power B. And for Y, we have written ml minus 1 T to the power minus 2 whole raised to power C. That is the dimensions of your Young's modulus, which are same to the dimensions of pressure. Now solve this out. Here L is having power A. Here it is having power minus 3B. And in the last term, it is having power minus C. Similarly, M is not having any power in the first term. No M quantity was there. And in second term, M is having power B. In the third term, M is having power C. So you can easily write M is having power B plus C. And for T, you are having only one term in which T is involved. So you can write its power as T to the power minus 2C. So you can write it like this. I'm again telling you this thing, that M is having power B over here and M is having power C over here. When the coefficients are same and the powers are different, we can add the powers. So this is M to the power B plus C. Similarly for L, over here it is power A In the second term, it is power minus 3b. And in the third term, the power is minus c. That's why I've written a minus 3b minus c. And in the third one, that is for t, the t is involved only in one term. So we'll be having t to the power minus 2c. Now, you have to compare the power on the left hand side and the right hand side. So comparing of the power, we can write b plus c is equal to 0 because no m term is involved towards the left hand side. And a minus 3b minus c is also equal to 0 because no L term is involved towards the left hand side. But this minus 2c, it is equal to 1 because c is having power 1 in the left hand side and towards the right hand side, it is having power minus 2c. Both must be equal. So comparing LHS and RHS, we can write it like this. That minus 2c, it is equal to 1. B plus c is equal to 0 and a minus 3b minus c is equal to 0 again. Then solve it up. C comes out to be minus half from the first equation. And when you put it over here, b is equal to minus c, and minus c was already minus half, and b comes out to be half only. And we can calculate a from the third equation by using the values of b and c like this. So from first equation, we got c equal to minus half. You just take this minus 2 into the denominator. From the second equation, b is equal to minus c and minus of minus half, that is equal to half. Because the value of c is minus half, we have calculated from equation 1. And from the last equation, we can write a is equal to 3b plus c. The value of b was half and the value of c was minus half. We can calculate it up. 3 by 2 plus minus half is equal to 1. So the value of a comes out to be 1. All right. Now you have to put these values in equation number 5. That's what we are doing in these type of questions. So putting these values in equation number 5, you can write it like this, that T is equal to K L with power 1, D with power B. B is what? Half. And Y with power C. C is minus half. So you can write it like this. T is equal to L to the power 1, D to the power half, that is B, and Y to the power minus half, that is your C. The power is negative, it will go into the denominator. So you can write it like this. And since they are having half power, so it will be square root. So D to the power half is root of D, and Y to the power half in the denominator is root of Y. Then you can write it as a whole square root of D by Y. So this is the final required equation. If someone is having some doubt in this one, he or she is most welcome to ask up the question. I'm stopping a bit so that you people can digest this thing. Okay, so a lot of you people are responding that they are not having any problem in this one. So let me move towards the next problem that I've given you. I hope that you have written it in your notebook. So let's move towards problem number 2. Second problem that I've given you, it says the escape velocity v of a body depends upon acceleration due to gravity of the planet G, the radius of the planet R, and by mistake, when I've given you this problem, the third line, the actually final expression, it has been written over there that you have to find the expression for the time period T of the spring. But please make it a correction that we need to deduce the expression for the escape velocity of the planet. All right, because we are talking about the escape velocity only. So by mistake, that thing has happened over there. So please make it a correction that you need to deduce the expression of the escape velocity of the planet rather than the time period of the string, because that was the case for the first problem. But somehow by some typing error, it happened to be that thing. So I hope that you have got that thing and you have done it for escape velocity only. And still, if someone is having some doubt, please make it a correction that it has to be deduce the expression for escape velocity of the planet. All right, rather than the time period of string. So that we have done already in the problem number 1. Now solving it up from the equation, you can write it like this, and it has to be solution 2, not solution 4. It has to be solution 2. So let me write it for you, and then again going back. Fine. So according to the question, we can write it like this, that v velocity is directly proportional to g to the power a. G is your acceleration due to gravity, and this v is also proportional to the radius r to the power b. So this is our equation number 2. Now combining these two equations, we are having V proportional G to the power A, R to the power B. And when you remove this proportionality sign, there will be one constant, that is K. So V is equal to K, G to the power A, R to the power B. Now, when you solve it up, you have to write the dimensions of the quantities that are involved towards the right hand side and the left hand side. So towards the left hand side is V, V is LT minus 1. And G is acceleration due to gravity, that is some kind of acceleration. So it will be having dimensions LT minus 2. And R is the radius, that is length. So it will be having dimensions as capital L. So you can be writing it like this. LT minus 1 is equal to LT minus 2, that is for your G to the power A. And for R, you have written L to the power B. Now, solving it up, towards the left hand side, L is having power 1, and towards the right hand side, L is having power A in this term and B in this term, so that will be A plus B. And T is having power minus 2A. So you can write it like this, separating the terms with the respective power. L is power A in the first term and with power B in the second term, so it will be L to the power A plus B. And for this second term, T will be having minus 2A. Now, when you compare both the terms, A plus B, it is equal to 1 because L is having power 1 over here, and it is A plus B for L in the right hand side equation, and T is having power minus 1 towards the left hand side, and towards the right hand side it is having minus 2A. So you can be writing it very clearly, you can be easily writing it like this, that minus 2A equal to minus 1 and A plus B equal to 1. So you can write it like this. Minus 2A is equal to minus 1 and A plus B is equal to 1. Now solve for A from the first equation. So A will be equal to half. When you solve this one up, it will be equal to half. And after solving for A, you need to put the value of A over here. B is equal to 1 minus A. So you can be solving it like this. So A comes out to be half and B is equal to 1 minus A. A we have obtained as half. So 1 minus half is again equal to half. So both A and B, they are equal to half only. Putting the values of A and B in equation number 4, you can write it like this. V is equal to G to the power half, R to the power half. And now, when some quantity is having power half, we can write it as root. So the final expression, we can write V is equal to K root of GR. So this is the required expression. I hope it is quite clear to you. And please respond that whether you got this thing or not. I'm stopping a bit over here. Please respond to this if you are having some doubt or not. Okay, fine. Very good. So a lot of you people have got it. I can see that you are responding as you are having not any doubt in this one. So very nice to see that. Very good. Now let's move towards some other kind of problems that are actually some typical problems of the dimension analysis, and a lot of these questions, these kind of questions, they may ask in the competitive exams as well. So you people need to go through them as well. Okay, and you have to be very much attentive in solving those problems to look at them in such a manner that how you can use the dimensions to solve those problems. So that I have put under a head miscellaneous problems. All right. So let's go through some more problems, and they actually are combination of one or two applications of the dimension, and you people have to solve them up in order to get to some more deeper insights of this dimension analysis. So let's start that. Some miscellaneous problems, and one problem, it says that a balloon has a mass small m, surface area capital A, radius of curvature r, velocity v, and density rho. The resistive force acting on it is given by. So they have given you 4 options. All right. So it is one problem that was asked in IIT once. All right. So in the JEE Mains exam, they have asked this. So when you look at this problem, you may be applying a lot of concepts of force or the laws of motion to derive the formula, but that is not the case. Here, you need to apply the concept of dimensions to find out which formula is correct. So what we can do is that we can compare up the dimensions of the left hand side with the dimension of the given formula. And if one of the formula satisfies the dimensions, we can say that this formula may be that formula and it is the correct formula. So let's solve this one. Okay, so if you want to write it, I am stopping a bit for around 30 seconds so that you will be having something in your notebooks. Please write it down and then I'll be explaining it. In such type of problem, we need to apply the dimensions of the left hand side must be equal to the dimensions of right hand side. That is the principle of homogeneity. So let's try to solve it up. Option A, we need to check for the dimensional consistency of the equation. So option A, towards the left hand side we are having some force. So force is having the dimensions as MLT minus 2. So resistive force is kind of force, and the dimensions for force, that is of the LHS, are MLT minus 2. We need to find this thing, that which of these formula A, B, C, D will be having the same dimensions as that of the dimensions of LHS. So let's try it. Option A has the following dimensions. So for solving for the dimensions of option A, this whole quantity will be dimensionless. So we just need to solve for this thing. That is 2 rho VA upon R square. All right. Because anything inside the log must be dimensionless. So we won't be paying any attention to this quantity. We just be going for 2 rho VA upon R square. So for the rho, I can write ML minus 3. For V, I can write LT minus 1. For A, I can write L square, that is the area. All right. And R square is L square because the square of length. This L square gets cancelled out with this square, L square, and this L, when it will be multiplied by this minus 3, you will be having L to the power minus 2. So finally, you will be getting ML minus 2T minus 1. So this dimensions, they are not equal to the dimensions of LHS. So we can say that A is not the correct option. All right. Also, we need to check the dimensions for option B. So let's go towards option B. And for solving up the dimensions of option B, we just need to solve the dimensions of 2 rho V square A by R. 2 do not have any dimensions. Rho is having dimensions ML minus 3. So V square is LT minus 1 square. That is L square T minus 2. When you square LT minus 1, you will be having L square T minus 2, and A is again L square, and for R you can write L. When you solve this thing up, this L, when it go into the numerator, it becomes L to the power minus 4, and L square, L to the power 4, they cancelled out, and you are left with MT minus 2 only. That are again not the dimensions of the quantity that is involved towards the LHS. So option B cannot be the correct answer. Now let's solve for the option C. We need to find the dimensions of option C. So we need to solve for rho V square A. All right. So rho is having dimension ML minus 3. V square is having dimension L2 T minus 2, and A is having dimension L square. So you can be writing it like this. All right. So when you solve this up, L square multiplied by L square, it is L to the power 4, and solving with L to the power minus 3, you are left with only one L, and finally you will be getting MLT minus 2. And these are the dimensions of the quantity, that is the resistive force involved towards the left hand side. So you can easily say that option C is the correct option. All right. So you can say it like this. Now your option C is the correct option. You can just take it. All right. So this is how you need to proceed when such type of questions arise. No need to go through the concepts of laws of motion and all that in order to derive of the formula, because it will really be very cumbersome to derive a formula. All right. In around 5 minutes. So they are just actually checking the concepts of dimensions to test whether you people are knowing this thing. Two things: whether you are knowing the dimensions, and secondly, you are knowing the principle of homogeneity. That is, the dimensions of LHS must be equal to the dimensions of RHS. All right. So you can easily be doing it like this. Let's take one more problem, more typical problem. All right. And if you are having some doubt in this one, please ask me now, or I should be just moving towards the next problem. Okay, I'm just stopping a bit. Please ask me if you are having some doubt. So a lot of you people have got the concept and not asking for any doubt, and they are saying that they have solved it and they are quite clear in their concept. So just move towards problem number 2. In problem number 2, this is one another kind of problem that was again asked in IIT some years back. So it says like this, that if the velocity of light denoted by small c, the universal gravitational constant denoted by capital G, and the Planck's constant denoted by h are chosen to be the fundamental units, find the dimensions of mass, length, and time in terms of c, g, and h. So now the dimensions for mass, length, and time needed to be obtained if we have changed the fundamental units. See, in SI system, we have taken the fundamental units as mass, length, time, and 5 other quantities. But now they are saying that the fundamental units are changed to c, g, and h, and we need to find the dimensions of m, l, and t in terms of these things. Like m has to be equal to some terms which are involving these with some power. L has to be equal to some product of terms involving these c, g, h with some power. So that's what we need to find out. All right. So let's proceed with these kind of problems, with how we need to solve them. First of all, write the dimensions of the quantities that are given to you. So we are given c. All right. So c is having dimension lt minus 1. We know c is a velocity, some kind of velocity. So it is having dimension lt minus 1. Again, we are given g. G is universal gravitational constant, and it is having dimensions m minus 1, L3, t minus 2. We have done it when we were doing the dimension formula for different kind of constants. We have done this universal gravitational constant g. It is having dimensional formula as m minus 1, L3, t minus 2. Again, we are having h, that is the Planck's constant, and it is having dimensions m, L2, t minus 1. All right. Now we need to find out m, l, and t in terms of g, h, and c. So we need to do some operation. We need to do some mathematical manipulation in order to eliminate out the other terms. All right. Like we can do one thing. If we need to eliminate t and l from these terms, what we can write? We can write it like this. That h multiplied by c, when we multiply h with c, what we are left with? m, L3, t minus 2. And L3, t minus 2 is there in g. So if I multiply h and c, and divide it with g, this l and t terms will be cancelled out. I know this. I can just observe it and I can find out. All right. So that's what I've done. That h multiplied with c divided by g, and in that case, I can write it like this, that h is having dimensions ml2 t minus 1, c is having dimensions lt minus 1, and g is having dimensions m minus 1 l3. All right, l3 t minus 2. See, this is one possible solution to this one. You can be solving it in any other way. You can also be taking g divided with h by c. All right, so that also be one possible solution to this one. In that case also, so this is something that clicked to my mind just by seeing it out, that I can just eliminate these LMC by doing this. You can be solving it in any other way, will be getting the same result. All right, Chaitanya, I hope I'm clear. Okay, fine. So h c by g gives you m square, but you have to find the dimensions of m. You have to find the dimensions of m. So what you will be doing? Take the square root both sides, isn't it? If you are given x square, how you find x? Take the square root. Similarly, we have found out the dimensions of m square in terms of h, c, and g. In order to find m, we have to take the square root. So you can be writing it like this: that m is equal to h to the power half, c to the power half, and g to the power half. And with this g, when it will go into the numerator, the power becomes minus. So finally, you can write the dimensions of m. They are equal to h half, c half, g to the power minus half. So this is how we have expressed m in terms of h, c, and g. All right. So this is one method of doing it. You can easily be writing like this also, that g divided by h by c, and then you'll be getting 1 by m square, and then you'll be solving it up for m. All right. So this is how we have expressed M in terms of H, C, and G. Now we need to express L in terms of H, G, and C. So let's do that. Again, if we do the division of H and C, so this C gets cancelled out with the C, and one L gets cancelled out with one L, and we are left with ML only. You can see this. If I perform this operation, you can easily be writing it C by H. All right. That doesn't matter at all how we are writing, but our aim is to eliminate out one quantity. So now we are eliminating C because we are knowing the dimensions of M. So M's dimensions we are already knowing. So now you can easily be writing the dimensions of L is equal to dimension of H, C multiplied by dimension of M. You take this M in the denominator of this H by C. All right. So you are left with dimensions of L is equal to dimensions of H divided by dimension of C multiplied by dimensions of M. Dimensions of M you have just found out. H to the power half, C to the power half, G to the power minus half. We need to express this L in terms of H, C, and G only. That's why we are replacing this M in terms of H, C, and G. We have written it like this. So in place of this M, I have written it H to the power half, C to the power half, G to the power minus half. And this C to the power half, when you multiply it with C to the power 1, it becomes C to the power 3 by 2. And when you take it to the numerator, you are left with H to the power half, C to the power minus 3 by 2, G to the power half. So these are the dimensions for L. Now we have expressed L in terms of H, C, and G. All right. Finally, we need to find the dimensions of time in terms of C, G, and H. So we can do this. C is equal to LT minus 1 from our this equation. So T becomes L by C. When you take this T towards this denominator, it becomes T to the power 1, and C comes into the denominator of L. So you can write T is equal to L by C. You know the dimensions of L, just we have obtained in our equation number 2, H to the power half, C to the power minus 3 by 2, G to the power half. You can write it over here, and you'll be getting the dimensions for T as H to the power half, C to the power minus 3 by 2, G to the power half divided by C. And finally, when this C, it goes into the numerator, again it becomes H to the power half, C to the power minus 5 by 2, G to the power half. So these are the expressions of T, M, and L in terms of C, H, and G. So this is how we need to proceed when such type of questions come. All right. Try to eliminate out one of the other quantities. Try to get the dimensions of first quantity. Then we can use the dimensions in some other eliminations to get the dimensions of the other quantity. All right. That elimination you can do by any of the methods, either by multiplying or by dividing or by squaring and multiplying or by dividing and squaring. Any of the methods you can apply by which you can do the elimination and find out the dimensions for one given quantity. Then you can use that dimensions in some other elimination process that you are doing. All right. So this is one way to proceed. I hope I'm very much clear in this one. And still, if you are having some doubt, please go ahead with your question. Let's proceed. Let's proceed towards the next topic that I want to discuss. And I leave it to you people to solve more miscellaneous type of questions and more competition questions from some help book. Please solve them, and you will also be finding a lot of questions that are in the worksheet that I'll be giving you. All right. So let's proceed towards the limitations of dimensions. So these dimensions, they are having certain limitations. Some drawbacks are there of using the dimensions. So let's discuss them one by one. First dimension, it says that the method of first limitation, it says that the method of dimensions, it do not give any information about the dimensional constant k obtained in the equation. So we are frequently obtaining the k, that is the dimensional constant, but we don't know what its value is, whether it is 2 pi, 6 pi, or whatever, 5, 4, 3. All right, but with the numerical value of this dimensional constant k, that is not given to us by the methods of dimension. So this is one limitation. All right. Again, it fails when a physical quantity depends on more than 3 physical quantities. So if there lies some physical quantities which are depending on more than 3 physical quantities, then we are not able to solve that one. All right. So maximum it can solve the equation for the quantities that depends on three factors. More than that, this method gets failed. Also, it fails when a physical quantity is sum or difference of two or more quantities. It may be possible that one quantity is obtained by summing of two other quantities or by taking a difference of two other quantities. But when such thing happens, we will not be able to find out the formula for that quantity using the methods of dimension. One example I can give you like this, that this formula is for distance s equal to ut plus half at square, and this s, it is the sum of two quantities. One is ut, other is half at square. We are not able to obtain this formula from the methods of dimension. It only works when the quantities are product of the two or three quantities. All right. So then it gets failed. Again, the methods of dimensions that fail when the relations they involve trigonometric, logarithmic, or exponential functions. So if these kind of functions are involved in some equations, we are not able to get any information for those functions actually. So this method gets failed in deriving of the relations that are involving trigonometric, logarithmic, or exponential functions. And finally, when there are dimensional constants like g and h are involved, so there are two kinds of constants. One is the dimensionless constant, that is k, which is not having any dimension, and other ones are the dimensional constants like g and h. They are having some dimensions. They are having some dimensions in m, l, and p. So when these constants are involved, then working with dimensions to obtain up the relations becomes very cumbersome. All right. So there are a lot of advantages also. So someone is asking that if there are so many limitations, then why we are using them? There are also applications and the advantages that we have done. We can check out whether the equation is correct or not. We can check out this thing that whether all the equation is homogeneous or not. So those things we can do with this, and we can roughly derive out the equations. And if we are able to derive out the equations roughly, then we are having some idea that how the system is going to behave, and experimentally we will proceed in that manner only. So if we are having some idea about something, then it is always fruitful and good rather than to move in the dark, isn't it? So that's why we are using the dimensions. A lot of applications I've discussed, and these are the 5 limitations. So sometimes in the exam they may ask this thing, that what are the limitations of dimensions, and you people have to keep these 5 points in mind. All right. Now, I'm also giving you some homework practice problems. So some different kind of problems I've tried to involve over here. First is for the dimensional correctness of the relation. So you are being given 3 relations are being given over here, and you need to find out that which of the formula is dimensionally correct. All right, so using the methods of dimension. Also, you need to find the value of constant k in this equation. All right, so what is the dimensions for this constant k in this equation? You need to find out, where all other quantities, where a is the area, t is the time fluid, t is the time, and v is the velocity of the fluid. So you need to find the dimensions for k from this equation. Capital V is your volume. All right. Also, you need to find the dimensions for quantity q from this equation, where t is your time period. All right, m is mass, y is Young's modulus, and L is length. You need to find the dimensions for quantity q that is involved in this equation. Also, you need to check the validity of the expression that is given to you, where all the symbols which are having different meanings. And one other problem, that is the interconversion of the units from one system to the another system, that I've involved over here. You need to find the value of 100 joule on a new system which has 20 centimeter, 250 gram, and half minute as the fundamental units of length, mass, and time respectively. Please try to solve these questions at your home, and please mail me. All right. So these questions you will be receiving with the PDF of this lecture itself. All right. So I'd hope that Barkha, you won't be having any problem in that one. That when you will be receiving up the PDF in your group, you will be receiving these particular questions. They will be involved over there. All right. So please try to solve these things, and that's all that I want to discuss for today. Thank you very much for joining up the class, and stay safe, stay blessed. Thanks a lot.